Okay, so here is the second part of the hand tools lecture that we're doing this week. So we got some text to go through, and we're going to do the stop and go thing. So we will analyze most of this stuff that we have here. We'll analyze it line by line. So that was the last picture that we stopped at during the last lecture. And of course, this is supposed to be funny. And as I said before, and I said it again, and I will say it again, I hope that these guys are just posing for a photo shoot to show some wrong things that can be done in an exaggerated way when it comes to safety. If that's not the case, then I don't know what to say. Anyways, all right. So hand tools and safety rules, we're continuing. Now let's analyze some of the stuff that is being written here. Never use tool, hand or power unless you are trained to do so. It's just one liner here, but it's loaded. This one line is loaded with content. And I'm just going to tell you one situation that happened to me once. Well, I had many situations over the 30 years in the industry. But I'm going to tell you this. Once I wanted to chop some tree that was basically removed in our backyard, and I wanted to cut it in pieces so we could use that thing in our wood stove in the basement. So one of my friends said, I'm going to lend you my chainsaw if you want. Yeah, okay, cool. So he brought the chainsaw. Yeah, there's this. This is how you started. Thank you. Bye. Just give it back when you're done. All right, so I'm standing here in front of the chainsaw, and I just thought, you know what? Let me just do a little research since I never used the chainsaw. So I'm not just going to take it and turn it on and start going at it. It's a power tool, and let's see what the safety notes are on that. So you know what? We live in wonderful times that all the information is available at our fingertips. So hey, hit YouTube, and I just punched chainsaw safety, and this thing just lit up with stuff. So I watched a couple of the videos, and after watching a couple of those videos, I decided that, you know what, I'm not going to use that chainsaw because I'm not ready for it, and I don't have the proper PPE. I don't have the proper personal protective equipment. Especially, I was not comfortable without having a face shield. I know you can see all bunch of people just using it and going at it without what I'm saying, which is basically I just wasn't comfortable without a face shield. And the reason for that is or was that sometimes in the trees there are hidden objects, like for example, you could have like a loophole lag, whatever that thing is called, I forgot, uh, to hang some things off the tree. And if you forget about it, the tree keeps growing, and over the years it will cover the whole thing. So you will never know that this thing is there. There could be lag bolts in there. There could be nails. There could be all kinds of things hidden in there. And if you use the chainsaw, and if the chainsaw hits that thing, it bounces up like crazy, and it just bounces upwards. And usually when it does that, it just goes and hits you right in the forehead at a full speed. That's not a very happy situation. So I just wasn't happy. Just wasn't comfortable without having at least a face shield. And I didn't feel I was experienced enough to use that. So you know what? Better safe than sorry. And I decided not to use that. That's just one example. But when you go along, you're going to come across all kinds of different power tools and hand tools. And let me tell you, if you're not comfortable with using that, something in the back of your mind tells you there could be something. It could be for a reason. So, be conscious of things like that. Always, if you're not sure about something, just don't use it. And there's that thing, there's that saying, knowing enough just to be dangerous. Because if you don't know anything about something, of course you won't be able to even approach that. But if you know just a little bit about something, and if there is a risk of if there's a chance of you getting injured, And if you're not completely 100% or 100%, 10% familiar with the way to use that tool, don't use it. Right? That's the idea of knowing just enough to be dangerous. Right, so inspect the tools. Here's the next slide. Inspect the tools each use and replace or repair if worn or damaged. Okay, so the idea behind this is that if the tool that you are supposed to use is not in the condition that it's supposed to be, which means the way it's structured is altered for whatever reason due to a damage or somebody modifying that thing in a way that they don't know what they are doing, then the tool is not in the condition that it's supposed to be, which means the way it behaves is also going to alter. So when the tool behaves differently, you are going to compensate by the way you're gripping that tool, by the way you're holding it, by the way you're applying pressure here and there, whatever the purpose of that tool is. You are going to accommodate the condition of the tool with the way you're using it. And then so you have a double whammy there. First, tool is not in the condition that it's supposed to be, plus you're not using it the way you're supposed to. Bang, there's a recipe for well, for something to happen. And usually when something happens in that way, it's something that you don't want to happen. Right, so that's the idea. Clean the tools after every use. Well, that's the maintenance. You gotta care for the tools. The tools are there for you. The tools are there to help you do your job, to help you do your work. Take care of them. They will thank you. And if you don't take care of them, they will let you know that you should. And is usually, as I said, it will be in a way that you don't want to happen, right? So these two go together, kind of, right? Then there's the third, well, the fourth line here, the next one line, keep cutting edges sharp. Well, cutting edges are cutting edges and they're supposed to do the job, which is cutting. And the only way for things to be cutting, they have to have sharp edges. So if there is a tool that is supposed to have sharp edge and it doesn't, then of course the way it is going to behave is going to alter. And again, you are going to alter the way you are using that tool. Then again, we'll go back to what I just said before, a recipe for something to happen. Never test a cutting edge with your fingers. So if there's a knife and if you're not sure if it's sharp enough, don't use your fingers to test the cutting edge. Test on scrap material instead. Do I need to explain that? I don't think I have to explain that. All right. Carry tools correctly. Never put sharp or pointed tools in your pockets. Well, your pockets could be in your pants pockets, or pockets in your clothes. And when you're moving along, you're bending to pick something up or position your body to do certain job certain way. Your body or our body is flexible in order to accommodate different tasks that we're supposed to do. The tools were sharp edges with sharp edges, they're not flexible. So if it's in your pocket and your body adjusts certain way, that thing will not follow the curvature of your body changing positions. And and yeah, go catch a dog. All right, I'll be back. My dog ran away. Catch that dog. Okay. So when you're changing the position of your body, that thing will stay straight and it could actually go into your body. Or you might have some kind of a knife or a screwdriver with sharp and pointed edge, tip in your pocket and you forget about it. And then you do something and then, uh-oh, something is in me that is not supposed to be. And well, yeah, that's as far as I'm going to explain that. Carry tools correctly, never put, okay, so we just did that. Lightly oil tools and store them clean. Lightly oil metal tools and store, it should be them clean. Store them in clean, dry place to prevent rust. Well, if the tool gets rusty or succumbs to corrosion, then of course the behavior of that tool is going to change. And we go back to what I just said before. Wear personal protective equipment. Here's the story that I just told you, right? Wear personal protective equipment such as safety and goggles. We talked about that. Safety glasses, safety goggles, they're two different things. Face shields, gloves, etc. as required. And remember this little short story I told you about not wearing safety glasses when I got my first ever job repairing equipment at the music store? What happened was that I said to myself, yeah, nobody's behind my back drilling me to wear my safety glasses. So, you know what, I'm just going to do it without. Nothing's going to happen. And of course, something did happen because the piece of wire that I was desoldering from a connector, it spring loaded upwards as it disconnected physically from the jack or the connector, and the solder was still hot. So I got a drop of solder right in my eye. I was lucky that nothing happened to me with that. Right? So yeah, there's a reason why we wear the safety glasses and say face shields and gloves and whatnot, whatever we require to wear. Do not use tools if its handle has splinters, burrs, cracks, splits, or if the head of the tool is loose. Well, again, there goes this goes to what we just talked about a couple minutes ago. uh, then the condition of the tool is altered, and you're going to accommodate the usage or using the way you use the tool in order to do the job, and you're not going to do it correctly, and the tool is not going to behave correctly. Again, recipe for an injury. Right? Do not use impact tools such as hammers, chisels, punches, or steel stakes that have mushroomed heads. What are mushroomed heads? Here's an example of a mushroomed head. It looks like a mushroom. This is supposed to be nice and solid one piece, so you could hit it with the face of a hammer, for example, in order for the sharp edge to perform the work that it's supposed to. But it looks like this tool has seen better days. Mm, and well, it should be replaced. What happens if you keep using it that way? There is a chance of one of those splintered pieces to come loose, and when they do that under an impact, then they don't just fall down under with the gravity. They shoot out because, well, when you hit that, you produce an impact. There's energy, so things can go places. And usually, what happens if they go places? They go to places that you don't want, like your eye, for example. All right, so that's the example of a mushroomed head. All right, let's keep going with this show here. Uh, do not carry tools in your hand when you're climbing, like for example, climbing a ladder. Carry tools in tool belts or hoist the tools to the work area using a hand line. We will cover that a little bit further when we talk about ladders and scaffolds. But basically, when you're climbing the ladder, your hands and your feet should be able to do the job that you're supposed to do at that time, which is climbing. So if you are holding some tools in your hand and you are supposed to use those hands to climb the ladder, then you are not doing, then you're compromising your safety. Mm, That's as simple as that. And what happens when I'm talking to, um, sometimes you will be required to work longer hours to complete the projects. You're going to find yourself in different situations. Those accidents have tendencies to happen more often when you are tired. Your awareness is not as sharp as at the beginning of the day. So if you develop proper habits of not doing this thing, period, then when you're tired, um, then you are going to be safer than not. Okay, I said that. All right. So that's as far as carrying the tools. We'll cover that a little bit further on how we're supposed to do this. Do not throw tools from one location to another, from one employee to another, from scaffolds or other elevated platforms. If you have a tool in your possession and your friend doesn't, and your friend needs that tool and they are a little bit further than the reach of your hand, then you walk towards them if you want to hand them that tool, or they walk towards you, or you walk towards each other so you can just hand that tool. Do not throw things from one person to another. Period. And there we go, screwdrivers and hammers. Let's talk about the screwdrivers. Well, self-explanatory thing. Always match the size and the type of a screwdriver blade to fit the head of the screw. If you don't, you can damage the screw to the point that you won't be able to turn it. Or sometimes when you have to apply a little bit more pressure and you're going to be in a position that something can happen, you have to be extra careful, then your hand can slip and you can hit something with your hand, or you can lose balance, or whatever else. The list goes on. So if it's a Robertson screwdriver, Robertson number 2, then you use Robertson number 2 for that screw. Right? If it's a slotted screw, you use a slotted screwdriver. If it's a Phillips screw head, then you use the Phillips screwdriver and you use the right size. And how do you choose the right size? Well, the simplest thing is if it doesn't fit 100%, then it's probably the wrong size, right? Okay. Do not hold the workpiece against your body while using a screwdriver. Well, what happens? We're having some sort of a device. Oh, let's just have a little bit of railing from a camera. And let's say you're going to have a screwdriver. Now you can see that. Here is a device. And you're going to use a screwdriver to tighten some screw. Look what happens. You're holding it here with your hand, with this one, and you're putting pressure towards. If something happens, if something slips, if something breaks, that screwdriver is going to go right into your hand. So make sure that you're conscious of things like that. Put the thing against some sort of surface, so if something slips, it goes onto a table or some sort of countertop, and so on. Do that kind of stuff. Be conscious of things like that. The other thing is, if you have a knife, let's say this is a knife, and you're supposed to scrape something, and you're supposed to cut something off, and let's say you're going to do it towards you. So what happens if something lets go all of a sudden? You're going to drive that thing into your own body. That is not a happy situation. Or that picture right here. There. Here's one good example. You're cutting something with the sharp knife, and if something lets go all of a sudden, where is the knife going to go? So always look beyond the direction of the applied pressure. Yeah, well, don't want to know what happens if something lets go all of a sudden there. All right. So I can't give you all the possible situations because life is a fluid thing. The situationability of life, I think I just invented a word, is a fluid phenomenon, fluid occurrence, and nobody knows exactly what's going to happen. But just when you're performing certain type of a task, be conscious of this type of things. All right. Do not force a screwdriver. Okay. Against your body. Okay. Do not force a screwdriver by using a hammer or pliers on it. What happens if you force a screwdriver when you're using a hammer? Well, the screwdriver is made out of certain metal that is not supposed to be hit. It's not meant for an impact. What happens if you have a material that is not meant for impact and you give it an impact? It can break, it can chip, things can chip away and they can fly away right into your eyes. That would be the worst thing. Or anything. Sometimes impact can be so hard that the pieces that fly, they could have certain velocity, and if they have certain velocity and if you have certain mass, they have certain energy, and they can penetrate some of your skin. The worst thing can happen is can get some in your eye, then you can lose an eyesight, right? Now, or do not force a screwdriver using hammer or pliers on it. The same thing. If you use pliers, you provide extra pressure that the tool was meant to handle. Hand tools are designed to for forces applied to them that you are able to provide with your hands. If you are going to improvise and extend some of the arms or apply some other devices that are going to apply some extra pressure on them that the tool is not meant to handle, then again, things can break, things can chip away, so your hand can slip and you can hurt your hands because you're going to hit against some surface, or pieces can fly, metal pieces can, or plastic pieces or whatever else, they can fly away from the point of origin and they can find a destination in your face, maybe sometimes. Do not use a screwdriver as a punch, chisel, pry bar, or nail puller. Well, this statement is pretty much almost the same as that. So, but there are two different statements, but the reasoning behind them is just the same as that. Right? All right, so these are the basic kind of things about the screwdrivers. Let's see what we can see, analyze the hammers. Hammer is a relatively simple thing, which is meant to use one thing. It's to hit things. Yeah, it's to hit things, right? Okay. But some of the safety that goes behind it might be a little bit complicated, more complicated than not. And as far as the safe using of a hammer, it's an object that has mass, and you wave it around, so not wave it around, you use it to strike things, you use for impact action, and you have to have a little bit of a consciousness when it comes to that. Safety, you have to be safety conscious, always. Do not strike nails or other objects with the cheek of the hammer. Remember what the cheek of the hammer is? Here's my face, here's my cheek. So this is the side of the hammer. It's not meant to do that. Do not strike a hardened steel surface, such as a cold chisel. Remember what cold chisel is? This is a chisel, or one of the shapes of a chisel. Here is the head that is meant to withstand impact, and here's the working edge of that, and you hit that for the edge to do the work. And when it comes to cold chisels, it's basically a chisel that is supposed to work on metal, but excuse me, you are not required to heat any of the surfaces. Sometimes when you work on metal, you're supposed to bring them to a higher temperature so you can do a certain type of job. But cold chisel means not, it's not like extra cold. You don't have to put it in a refrigerator to keep it cold. It's just basically you don't need to. You are not required to heat. The procedure does not require heat for processing. Yeah? So that's what cold chisel is. Um, so so do not strike a hardened steel surface such as a cold chisel with the claw hammer. Remember the claw hammer? Claw hammer is used for driving and removing nails only. It's not supposed to do a metal on metal impact contact, such as striking chisels. The steel that is used to make that kind of hammer, the way it is made, the way it is processed, the way it is treated, is not meant for that piece of object to hit metal. A ball peen hammer is made for that. So if you want to strike metal objects such as chisel, you should use the ball peen hammer. Do not strike one hammer against another hammer. It's almost funny that this thing is mentioned. However, apparently there is a reason why this thing is here. All right, pliers and saws. Do not use pliers such as wrench or hammer. Right? Sorry, do not use pliers as wrench or hammer. If it's pliers, then it's meant to, there are different type of pliers that are designed to produce certain type of grips, and they should be used, tools should be used for that intended purposes. If you use them for purposes other than intended, then you are really raising the risk of you getting hurt. So if it's side cutters or wire cutting pliers, don't use it as a hammer to strike nails. Go and get a hammer and use that. And for the nails, it would be claw hammer. Right? All right. Do not attempt to force pliers by using a hammer on them. What would be one of the examples? Let's say you have wire cutting pliers and the wire that you're trying to cut is kind of harder than those pliers are meant to handle. So you would just put that and you would hit the head of the pliers with the hammer in order to produce impact so you can cut the wire. Don't use that. This is not the way it was supposed to be used. The metal that is there, the structure of that metal is not meant to handle impact. And if it's not meant to handle impact, I'm going to say again and again and again, just in case somebody was sleeping and not listening. You hit things like that that are not meant to be hit. You provide impact to a metal that is not supposed to handle impact. It will chip, it will, and the pieces will fly. Where are they going to fly? Who knows? But usually it's exactly where you don't want them to fly. Do not do not slip a pipe over the handles of pliers to increase leverage. The handles have certain length, and if you extend the length, you have better leverage. You apply less force. The further you get away from the pivot point, then the cutting edge has more power. Well, the tools are meant to, they're designed with a certain length of the handles that are supposed to withstand certain power, certain energy provided by your hand. If you extend the handles by sliding a pipe onto them, you are you are providing more energy that the tools was supposed to handle. And then again, things can slip, things can fall with a high speed. You can hit yourself on something, you can hit your hand on something, or things can just basically slip away at a high speed and they can fly where you don't want them to. Right? Do not use pliers to loosen or tighten nuts. They are not designed for that, and they will slip off the nut. And when you have a high grip and you apply high power, then when something slips, it slips very quickly and it flies very quickly and it flies very fast and it flies with energy. And where is it going to stop? Well, if your hand hits some hard surface, then your hand is going to stop on that surface with an impact. Enough said about that. Saws, do not use an adjustable blade saw, such as hacksaw, coping saw, and other keyhole saw, whatever saws, if the blade is not taut. What does it mean? The blade, when it has an adjustable blade saw, then the blade's tension can be adjusted. And for example, when I give you the little bit of a demonstration, live demo during the lab in our class on how to use a hacksaw. It's not as, here's a hacksaw, go use it, all right? I'm going to show you how to tighten the blade properly, how to position the blade properly, so the job that is being done by that tool is done in a proper manner, which means there's always a chance for you to get hurt, no matter what you do. But um, if you do everything that you're supposed to do, then you are greatly reducing the risk of you getting hurt. Right, so for example, in a hacksaw, the blade is supposed to have the proper tension. If it doesn't have enough tension, it will bend on you. It will give. it will go out of shape. And then when you are pushing, when you're applying pressure on something and something goes out of shape all of a sudden uncontrollably, then there's no way of what is going to happen in terms of where your hand is going to go, what your hand is going to hit, what is going to fly out, what can go in you. And that's probably the biggest thing. Right? All right. Do not use a saw that has a dull saw blades. Same analogy with the knife, sharp knife or dull knife. If the blade is supposed to be sharp and it's not, then the way the tool is going to behave is going to change. It will change. The tool will change its behavior and you will try to compensate for that change, which means you're going to hold it and use that tool in a way that is not meant to be used. Again, recipe for an injury. What do we here? We'll have here, put downward pressure on the blade on the forward stroke of the saw. We will take care of that when we'll give you the demonstration during the lab on how to use the hacksaw. We will use the hacksaw to cut EMT, electrical metallic tubing, which basically are metal pipes for the wires to go in. It's a raceway. It's called raceway as well. And a pathway that assists the cables or wires to go a certain way and closes them. It's called raceway, right? So EMT, electrical metallic tubing, is what we're going to cut during this term. That's when we do the pipe bending. Right? So we will show you those techniques of how to properly apply the pressure on the hacksaw and the forward and backward strokes. All right, next slide. Always securely fasten the object that is being sawn so it does not slip. Well, if your saw is not in the right condition, then the saw can break. And when the object that you're cutting is not fastened properly, then it can fly out of the holding. And then again, you're applying certain amount of pressure and you are expecting that object to stay there. And if it flies away from its mounting, then, well, under the kinesthetic energy that you're going to have, it's going to go somewhere. All of a sudden, you also have that potential energy, and they all are going to accumulate, and your hand is going to slip, and it's going to go farther than you want it to, in a very fast way, which means you can hit something with your hand. And usually, when that happens, your hand gets injured, not that object. All right, selecting the proper tools. How are we doing with time? We're doing good. What factors must be considered before selecting a tool? And here is the big word, ergonomics. Before I continue here, I'm going to say this. If you have a tool that is sitting in your kitchen drawer, and you use it once in a blue moon to do something, yes, if you use it incorrectly, then you're still putting yourself at risk of getting injured. But if you're using it all the time, and if you're using it incorrectly, or if you don't, if you have a tool that doesn't fit your hand properly, or whatever you're doing doesn't match the task, and if you're using it all the time, then you have that much more risk of getting injured. Right? This is basically pure statistics, and I'm not a statistician, and I still know that. So should you. All right. Ergonomics. When you're using a tool on a regular basis, first of all, don't get the cheap tools. They will hurt you. Period. Use proper tools, brand names, and not only that, use the tools that fit you the best. So that has to do with the ergonomics. There could be two different people, and for one person, that specific tool, brand name tool, whatever it is, properly done, it will work fine with the hands of one person. Somebody else can have a little bit, can be built a little bit different, so they might have to use the tool that is a little bit, maybe different brand or maybe different size or whatnot. It has to do with ergonomics. Now, sometimes, and this is when you're using the tools, I'm talking about you using the tools on a regular basis, regularly at your work, 8 hours a day, to make money, so you can put food on your table and food for your family, so you can support yourself. All right, Nicholas, did you cut your dog? Is it back yet? Um, so, sometimes you will be required, good. You might be required to select a tool for a production line. Right? So you could be holding a supervisor, you could be a supervisor somewhere, um, in some plant, production plant or whatnot. And you might be given a task of purchasing certain type of tools because there's a production of a new product, and what, guess what, we need some kind of a tool that needs to do this, that, and the other thing, so we need to go and purchase some tools. You're not going to call a store and say, hey guys, do you have so and so tool? And they're going to say, yes, okay, can I have 500 of them? You are going to research about what are you looking for. I'm just trying to help you with this. What is it that you're going to be looking for? Well, first is going to be the ergonomics, functionality, safety, and ergonomics. Functionality will let you do the job properly so it can be done. Safety, the way the tool, whether it's safe to use or not, will increase or decrease your chances of getting hurt by the tool immediately, like an immediate injury, which means your hand slips and you hit some sharp object and you get cut on your hand. So that's an immediate injury. The ergonomics is going to prevent you from the prolonged exposure, and those are tricky. Those injuries for due to long exposure. If you're using something incorrectly for a long time and you don't get injured immediately, but if you're using it over a long time, you might develop certain conditions that pretty much creep up on you with time. And those are next to impossible to reverse. And then you're going to be pretty much, you'll be sorry, you'll be missing the stuff that you were able to do before, or you're going to be missing not having pain because, well, I always say that do a little experiment. Get your pinky and pinch your pinky with the other hand to the point that it starts hurting. And then what are you going to do? Well, you're going to release so you don't hurt anymore. And then maybe you can massage that pinky and you're good. You're comfortable now. But imagine that something happened that causes the pain and there's nothing you can do to stop that. And it's there all the time. Then it's with you all the time. And it can create, more than slight discomfort, right? So ergonomics is quite important, and it requires a little bit of knowledge so you don't get hurt due to long exposure to certain procedure or using certain tools. Right? All right, let's go again. The factor that most often is overlooked is the ergonomics of the tool. Does it fit your hand? Is this the right tool? Is it the right fit for the job? So can the tool do the job? Does it fit your hand? Does it fit your body properly? Right? A tool becomes ergonomic only when it fits the tasks you are performing and it fits your hand without causing awkward postures, harmful contact pressures, or other safety and health risks. So if you are a supervisor or some sort of admin person in certain company, and you are giving the task or choosing certain tools, you are going to look at the ergonomics, you're going to look at the functionality, and you're going to look for the safety. And if you buy one or two of these tools and somebody complains on the production line or some issues arise, then okay, if it's not expensive, you can go and get another tool. But when you are supposed to get maybe 2000 or 500 of those tools, then you're going to have you're going to have some explaining to do with your superiors, that how did you research that tool. So I'm just giving you some ideas here when it comes to that. So there, if you use the tool that does not fit your hand, or use a tool in a way that was not intended, you might develop an injury such as, and you can research those, carpal tunnel. You might have heard of that. Hopefully, you're not going to know too much about that by experience. So in order to not to experience that, some things would be nice if you did a little research on what carpal tunnel is. It's a carpal tunnel syndrome. What tendonitis is. It's better for you to know that ahead of time and how to prevent that than get it and then get the education by experience. And that's the experience you don't want. Or muscle strain. Just some examples here. These injuries result from repetitive movements that are performed over time or for a long period of time. Same thing. The damage occurs to muscles, tendons, nerves, ligaments, joints, cartilage, spinal discs, or blood vessels. Injuries such as these can be irreversible. They can last a lifetime. So that's why we're raising the awareness, giving you the awareness before something happens. Be smart before something happens. You're going to get smart one way or another, but you don't want to get smart after something happens, because then the knowledge is not useless, but would be nice if you knew things ahead of time so you can prevent that. Repetitive strain injuries, prolonged injuries, prolonged due to prolonged use of something or prolonged exposure. So repetitive strain injuries. These injuries can manifest as tingling, swelling in the joints, decreased ability to move, decreased grip strength, continual muscle fatigue, sore muscles numbness. I'm just reading those. Change in the skin color, blah, blah, blah. There's a bunch of things that can happen. And again, I give you the pinky example. You pinch your pinky with your other hand and it hurts, and you release and it doesn't hurt anymore. But the problem is when the pain doesn't go away. Right? And that is because of repetitive strain injuries. All right. What do you look for when you are purchasing some tools? These are not hard rules, because sometimes you're going to have to wiggle one way or wiggle the other way, but this is a good starting point to look for things when you are selecting tools. General rule for average size person. Handles. And there is a handle for power tasks, which would be the regular size screwdrivers, or precision task would be when using miniature screwdrivers. And you might say, okay, miniature screwdriver is light thing, you just use a couple of fingers, but try to do something 8 hours a day using that miniature screwdriver. Your hand is going to hurt different way that if you're using this thing not correctly when you're applying power tasks, which means using the regular size tools, so to speak. Right? One hurts and the other hurts as well. And you don't want either of those, right? So let's see, when you're choosing the handle for power tasks, which is the regular tools, the handle diameter for the power tasks, and here's the handle diameter right here, should be 1.25 to 2 inches. 1.25 to 2 inches. Within that, then you can consider that tool to be comfortable to use for power tasks, regular size tools. Handle diameter for precision tasks should be 1/4 to a 1/2 inch. Then you can use that tool comfortably. You can say that the ergonomic the ergonomics are good, is good. Is. Power and precision grips, double handle. So that would be the single handle tools. There's a double handle. Open grip span for power tasks is no more than 3.5 inches. Then the tool is good. See, open grip. Closed grip for power tasks should be no less than 2 inches. Then you can consider that tool to be comfortable for the average size person. Now, let's see for precision tasks, open grip span for the precision tasks should be no more than 3 inches, depending on the tool. Then the closed grip span for precision task should be not less than 1 inch. Then you can say that the tool is comfortable to use. Ideas to consider when you're selecting the tool. Now you know what to look for, what to test for. There's a little bit more, but this is a good starting point. That's the last slide here. Considerations when selecting hand tools. For double handled pinching, gripping, or cutting tools, try to select a tool with handles that are spring-loaded to return the handle to its open position. Sometimes you're going to see tools that have a little prying outwards spring that when you squeeze that tool, it squeezes, and when you release, it opens by itself. That's better than using, because the other way is to use your pinky to open the tool. Well, it's better to have that spring if you can help it. Select the tool without sharp edges or finger grooves on the handle. What do I mean by this? What does it mean? Well, if you are supposed to apply pressure onto these handles, you want these handles to be relatively or properly smooth. Because if you have some sharp edges, you're going to hurt your hand. You're going to develop blisters or other things that are not comfortable. Also, what does it mean here is without finger grooves. So you would have a molded shape of that for your fingers to supposedly comfortably fall into places and stay that way when you're using that tool. The problem with that is, the same as the chair analogy, what's the best positioned chair on the market that you can get? What is the best position for you to sit in the chair? Well, there's no such thing. The best chair, the best ergonomically sound chair is the one that you can change the position of your sitting once in a while, because that's how you get not injured. If you sit or stand, or if you are in one position for too long, something is going to happen to your body that your body is going to get injured. We are not meant to be in one position for a long period of time. So that's why if you have smooth handles, and if you can slightly change the positioning of your hand while you're handling that, then that's the best way to go, because you're not always using the same repetitive motion that will cause repetitive strain injury. Okay. Select the fingers grooves. Okay, here. Select the tool that is coated with soft material. So when you apply pressure, it has a little bit of a give. Now, the other way to compensate for that is to wrap it up with something. But here's the problem with that. You wrap things with some soft material or cover it with soft material, you're changing the size of the tool. You're changing the way you're gripping that tool. You're altering the whole ergonomics of that, and that's not necessarily a good thing. So adding sleeves to the tool, handles, pads, surface, pads the surface, but also increases the diameter and the grip of the handle. And that was the last slide. And look, we have 2 minutes to go. What are you going to do with all that time? All right. So that was it for today, guys. Enjoy, and gals, enjoy your weekend, and tell me all about it when you return. All right. Remember, I'm just an email away. Have a good one, guys. Thank you very much.